the fun that's involved in moving us forward. I don't know, how many people here have put on Arduino workshops where you're teaching essentially electronics newbies how to use an Arduino and why it's important to us? Anyone? I'm going to assume people putting up their hand because they're shy. So essentially what we were doing, we were putting, doing like many hackerspaces, putting on an Arduino workshop. And what we're finding is you get somebody in here who's new to programming, new to electronics, they're excited about it, but they're starting from essentially zero. And we start with basic introduction. What is a microprocessor? What is programming? And then you got to talk about the basics of electronics, how to breadboard, how to control the SDK. And there's all these steps that they have to go through before they can actually press a button and see a blinky light, as Tony's so fond of. And we were finding that after a 2-hour process to get to their first success, we lost half of them. They lost interest. They've given up on the whole thing. And one of my goals is to go into schools and teach this stuff to fourth graders. I think they're capable of it if we present it in the right way, and if we show them why it's relevant, if we make it so that they can learn. They can learn, we've just got to do it right. And so what I wanted to do was short circuit the whole thing. Take all the stuff that gets in the way of pressing the button, and having that light light up, and move it to afterwards. Wait until they've got a whole bunch of successes in their pocket before they have to trace out a circuit and see how an LED does stuff, see how a pull-down resistor works with the button. Because those are things that are really mind-numbingly boring without seeing the payoff. And so we developed our CodeShield, which, if you put yours together, it should look something like this, except with the wire. By the way, the wires on the servo in this picture are on the wrong way around. If you're putting yours together, they go in the holes in the same order they come out of the servo. So be careful with that. So anyway, what the idea here was to do is take an Arduino, build a shield for it, build all the common inputs and outputs, switches, buttons, and then throw in some cool ones like the ball effect sensor, the light sensor. Have outputs like the piezo, like a relay with a terminal block attached to the servo, and of course the LEDs. And so what we can do is, in fact, give a student, a computer, give a student, a 4-line sketch that will have them pressing a button and lighting up the light. And then you can step them through the code. It's, 4 lines of code. How hard is it to do? And you get that first inkling of understanding. And then you can go back and deal with some of the other fundamentals that are underlying it. And then you say, okay, now that you've got your light on, I want you to switch it so you flip the switch and the light goes on. How do you think you would do that? And so I'm going to talk about more a little bit. First of all, I should say I'm not an electrical engineer. I kind of stuck at electronics. I don't know what I'm doing. I don't really understand any of the fundamentals I'm working with here. So if anyone wants to help me through, everything works. And essentially what I did to get to this point, this is our schematic for the whole thing. But to get to this point, I just went through the playground, the Arduino playground, pulled out all the individual circuits, slapped them all together onto a board. So the LED, photocell, piezo, and these are all on the wiki for the CodeShield. So you can reference them all. Rotary encoder is kind of fun. And again, the schematic here makes it look very simple, but of course there's some hefty underlying code to make some of these things work, like the rotary encoder. And there we go. So, as I said, me not knowing what I'm doing, there's a few things wrong with this board. And I don't really know if they're actually wrong with it, because they're simple. They're things that kids can understand and work with and reproduce, because they're so ridiculously simple. But if you try and run everything at once, things start to break down. You try to fade an LED in and out while you're running the servo, and you get weird stuff. Or if you try to run the thermistor to run a dimmer while the servo's going on, strange things happen. I don't know why, because I'm not one here. And so, yeah. But I guess what I'd like to do moving forward, the story of this is, so we had this idea of diode, threw together the circuit. We built our first 10 of them by doing program transfer, making our own boards. And then we started playing with the code and showing it around to people. We put it on our blog, and we got a lot of interest from Adafruit, SparkFun, and a lot of people in Japan. So we got a lot of hits from there. And we had a couple of interesting contacts, one from NASA, who said they'd be interested in using it in teaching their early robotics course that they do when they do a traveling roadshow, and they like the idea. And also, Conestoga College has signed on board the Dean of Electrical Engineering at Conestoga, has given the green light for any professor or student who wants to develop a curriculum or work in any capacity on this. They can do that on the school's dime. So that's kind of exciting for us. But I also want, because this is a hackerspace initiative, I want to get other hackerspaces ideally, if they're interested, in developing a curriculum for it too. I want to have a curriculum for fourth graders. I want to have a curriculum for high schoolers. I want to have a curriculum for adults who are good with analog electronics but don't know how to approach digital electronics. And get all these up in the wiki, and maybe, just maybe, find a new way of teaching all this stuff in a way that's much more approachable and get more people doing it. Someone asked me yesterday if I thought so the Arduino was going to take over. It's not going to happen, but it's a great entry point. And it's a great way to prototype a few things. And if we can get people understanding that, then we can change the world a little bit. A little bit. One of my sorry, I'm going to laugh around a bit here because I don't know what else to say. One of my Arduino stories. In our basement, we have a humidity problem. So we've got a dehumidifier that runs 24 hours a day. Except we watch movies in the basement too. So we go down and watch a movie, plug it, and then 2 weeks later we realized we forgot to plug it in again, and the basement was musty. And so what we did with an Arduino was have a little button you press, flips a relay for 3 hours, turns the dehumidifier off, and when the movie's done, we go on to bed or whatever, turns it back on. And it's little problem-solving things like this that you can take this and you can put it in the hands of pretty much anyone. It is simple enough to do that. So, I guess I'm not selling on Arduinos, but so my idea for actually developing a curriculum would be to sort of relate some of the ideas of what you can build with this with things that kids already have in their houses, and then say, all right, now how would we make this? And so, ideas, well, we start with a push-button light. That's the simplest thing. Right? The simplest thing would be just a light, I guess. But a push-button light is, it actually does something, so that's kind of cool. And then you can start talking about scenarios. You can say, okay, well, what happens if we fire a laser at the light sensor? And then we'll sound a buzzer if the light sensor goes to a certain point. Suddenly you've got a burglar alarm. In power off plan, right, where you talk about a thermostat control heater. You can very simply use this as it stands right now to light up a light post in a greenhouse that would keep it warm. You said your threshold temperature. And all of these things are things that the kids could do just with a shield straight out of the box. Internet control camera, there's no reason why you can't run a Python script on a computer, hook it up to USB, put a webcam on the servo and have it controlled by IRC or a web page or something. And so we can very easily, just with this board, start with essentially 0 and build them up. And then we have to also develop a curriculum to take them back down. Take them down to, okay, now you press this button and it's done something, but let's look at our circuit, let's look at what's happening here. You know, so here's our switch circuit. Yeah. Yeah, there's a switch circuit, so let's look at what's happening. Let's understand that we're not measuring current, but we're measuring voltage. Let's understand now we can look at how the breadboard is and stick with the breadboard. But you've got their interest. And so yeah, going forward, we've got a wiki. The URL on the wiki is on the boards. If you're interested in helping out or using it, anything like that, I'd be super happy. The badges, you should have, everyone have what you need to build one of these, including the Arduino now. Thanks to, what's that? Oh, there you go. Zach Upford, who's going to talk later, thanks for all of your badges. So I would say thank you very much. Yeah, if you'd like to help me change the way we teach electronics, I'd love to have your help.
Simon?
Yep.
If I were to pick up the number of those badges, what are they costing roughly?
When I do them in runs of 100, including the Arduino, they come to about 2,900. The badge themselves, about $14 each. As I said, there's probably some things that can be done to improve the board from to stop things interfering with each other. That, like it's possible the servos feeding back into some of the other components and whatnot. Whether or not I improve that or not, I'm not sure yet. Because I like the simplicity, I like it all to be something you can trace and understand. And there's no extraneous components to say, well, what the hell is this there for? If you run everything by itself, it all works. It's when you start running things together. And if you run everything at once, it'll probably blow the Arduino. Which again, maybe not a great thing, but I appreciate the simplicity. And I don't know if it's something that needs fixing or should be fixed. That's, again, it's beyond my pay grade to make decisions. There's a couple of things I should mention. A couple of people have asked me about the jumper that's on here. I think R10 is just a jumper. The reason that's there, that is the limit resistor on the piezos. And so right now people have been playing with their piezos around and you've been hearing them beeping. But if we've got 30 kids in the class, they're all going to turn into annoying little shits and try to make as much noise as they can. So the limit resistor there is if you're deploying this in a classroom, you put a 100 ohm resistor on there or something, and suddenly your noise level goes way down. But for a typical deployment, we want it sort of the values it is. And anything else we need to think about? The relay is a 1 amp 120 volt, so don't run anything too hefty off it. And yeah. Everything else is pretty self-explanatory. And we'll get sample code for every individual component up on the wiki soon, and then you can start mashing, combining, whatever. And yeah, I'd love to see you guys do it. I'm glad to get it into so many smart people's hands. All right. Any